Hello and welcome to Maths Table. In this lesson of Coordinate Geometry section 2.1, we are going to discuss what is coordinate geometry and what's the meaning of the gradient of a straight line. Coordinate geometry is basically a branch of geometry in which the position of the points on the coordinate plane are defined with the help of an ordered pair of numbers such as xy, which are also known as coordinates of the point. Now, what is a plane basically? This is an example of a coordinate plane. You can see that it consists of two axes. One is the horizontal axis, which is commonly known as x-axis, and a vertical axis, also called y-axis. Together, these two axes make up a coordinate plane or a grid in which you can construct numerous points, such as these 4 points, for example, A, B, C, and D. If we take the first point A, for example, we can see that this point A is defined by two coordinates 3 and 2. Now what is the meaning of these coordinates? The first one 3 is called the x coordinate of A, and this x coordinate means the distance of that point from the y-axis. So if its value is 3, it means that this point is 1, 2, and 3 units away from the y-axis. And a positive sign of this value indicates that this distance 3 is towards the right side of the y-axis. In contrast to this, we have another point B, which has an x coordinate -3. This minus sign means that the distance of this point is also 3 units away from the y-axis, but on the left side of the y-axis. So this is how an x coordinate indicates how far or how close the point is from the y-axis. Now the second coordinate written 2 here is basically called y coordinate of the point A. And the meaning of the y coordinate is that it's the distance of that point from the x-axis. So for example, if the value of this coordinate is positive, just like here, it means that this point is 1, 2 units above the x-axis. And similarly, this negative sign of the y coordinate indicates that this point is 1, 2, 3 units below the x-axis. So together, these two x and y coordinates define the exact location of the point on the coordinate grid. So this is the brief introduction of the coordinate geometry. Now let's move on to the next section about the gradient of a straight line. Now gradient in simplest terms is the steepness or slope of the line, and it's commonly represented by a small letter m. Now to better understand the concept of gradient, we can take a simple example of a ladder leaning against a wall. Suppose that a person has to travel up the ladder from point A to point B. Now, as he starts moving up the ladder, we notice one thing very clearly, that he's not just moving up, but he's also moving closer to the walls as he goes from A to B. So, this shows that he is actually traveling distance in two different directions at the same time. One in the vertical direction, which is known as rise, and another distance in a horizontal direction, which is called run. Now, if we compare this distance rise to this distance run, or if we take the ratio of the rise to run, then this ratio is known as the gradient of the ladder. And it tells us how steep the ladder is, whether the ladder is like this or in a much steeper position like this. So this is the basic concept of the gradient. Now we can extend this idea towards a graph of a straight line which is drawn on a coordinate grid. Suppose that we have this straight line passing through 2 points P and Q with coordinates x1, y1 and x2, y2 respectively, and we need to find out the gradient of this line segment. To do this, we can apply the same method as we did with the ladder, that we can calculate the two distances. One is the vertical distance rise, which is in this case the difference in the y coordinates of these 2 points, and the horizontal run, which is the difference between the x coordinates of these 2 points. Now together, this rise and run can be further accommodated in this ratio, rise to run, as before, and in this way we can obtain a simple general formula for finding the gradient between any 2 points on a straight line, y2 minus y1 over x2 minus x1. So this is how the basic formula of gradient is derived. Now we can study it further with the help of a few examples of different types of lines. Suppose that we have these two lines first. Now if we look closely, we can notice one thing which is common in both of these lines, is that when we move from left to right or towards the positive x-axis, we can see that both of these lines are giving us a rising trend, which means that if we move 1 unit from left to right, we are traveling 1 unit up in this line. And similarly, in the second line, if we move 1 unit towards right, we are traveling 2 units up. So this shows that both of these lines are giving us a positive value of rise for each unit positive run. And if we take the gradients of these two lines, we can see that both of the gradients are giving us a positive value. So such lines are called positive gradient lines, which rise towards moving right side. Now, one more thing to compare between these two lines is that the second line has twice the rise to run ratio as that of the first line. And we can also see that the second line has twice as much steepness as that of the first line. So this shows that the numerical value of the gradient tells us the steepness of the lines. So this is what we need to know about the positive gradient lines. However, we also have negative gradient lines. Such lines fall as we move towards the right side, such as in this line, if we move from point A to point B, when we move 1 unit towards right, we are moving 1 unit down. And also in this line, as we move 1 unit towards right, we are traveling 2 units down. So both of these lines are giving us a falling trend. And as discussed before, if we have twice the rise to run ratio, we get twice as much steepness. Similarly, for these two lines, we have twice the rise to run ratio for the second line as compared to the first line. And hence, we get the twice as much gradient for this line as compared to first one. So when comparing all these four lines, to summarize this, we get one conclusion that the numerical value of the gradients tells us the steepness of the lines, and the sign of the gradients, whether positive or negative, tells us the direction of the line, whether the lines are rising type or the falling type. So this is about the positive and negative gradient lines. Now, in addition to these lines, we also have a zero gradient line, which are parallel to the horizontal axis, such as this line. As we can see from this line, we can notice that it has 2 points A and B, and as we move from A to B, we neither rise nor fall. We're neither going up nor going down. So this shows that there is a zero rise between any 2 points on a horizontal line, and hence we get a zero value of the gradient because 0 divided by any number is 0. So that's why these lines are called zero gradient lines. However, we also have an infinite gradient line which is parallel to the vertical axis or y-axis. Now why is that so? Let's take these 2 points on this line. If we take the gradient between these 2 points, we notice that there is no run between these two. There is just a rise. So that shows that it has zero run, and any number divided by zero gives us an infinite value or undefined value. So that's the reason that this line has infinite gradient. So any line which is parallel to the horizontal axis will have a zero gradient, and any line parallel to the vertical axis will have an infinite gradient. Now the next section is about the relation of the gradients of two lines which are parallel to each other and two lines which are perpendicular to each other. Now first we'll look at this graph which consists of two lines L1 and L2. These two lines, as we can see, are inclined at the same angle with the horizontal x-axis, and so these lines are parallel to each other. And as their inclination is the same, then it shows that the two lines have same amount of steepness. Now, as we know from the definition of gradient, that gradient is basically the steepness of the line, and so we come to the conclusion that the two parallel lines have same or equal gradients. Now, in contrast to parallel lines, these two lines, which are crossing each other or meeting each other at right angles or 90-degree angles, such lines are perpendicular to each other. Now, the gradient of such kind of lines, which are meeting at 90-degree angle, are related by an equation m1 into m2 is equal to -1. This equation means that the gradients of two perpendicular lines are negative reciprocals of each other. So if the gradient of one line is 2, then the gradient of the other line will be -1 over 2. So this is about the relation of two parallel lines and two perpendicular lines. Now let's check an example about 3 points A, B, and C, and we have to show that these 3 points lie on a straight line. This also means that these 3 points which lie on a straight line are called collinear points. This is how what it looks like when 3 points lie on a straight line. As we can see from this diagram that if we take the gradient between these 2 points A and B, we'll get the same gradient as we find out between B and C. Or if we take the gradient between A and C, so we have a total of 3 pairs AB, BC, and AC. We can select any two of these 3 pairs and find their gradients, such as in this example, we have taken the gradient of AB, which comes out to be 1 over 2, and another gradient BC, which is also 1 over 2. So this shows that as the gradient of AB is equal to gradient of BC, the 3 points will definitely lie on a straight line, or these 3 points are collinear points. In the end, we would like to thank you very much for your valuable time in watching this video. For any questions or queries, you can contact us directly on our Facebook page or on Instagram. And for more updates, please subscribe to our YouTube channel. Thank you very much and have a nice day.